We have discussed the relationships between waves previously. These waves were kept separate and not allowed to interact. This podcast begins to cover the consequences of waves interacting with each other and gives us a means to describe these interactions. A special case of waves interacting is called a stationary wave. A stationary wave can be seen as another form of static equilibrium that we have discussed earlier. A stationary wave is created when two waves of the same frequency travel in opposite directions through the same media. The best way to describe a standing wave is through the use of a guitar string. A guitar string is the medium for the generation of waves. It is fixed at both ends, and so the particles are not entirely free to move. When you pluck a guitar string, you are displacing a section of the string. The rest of the string wishes to return this section to its equilibrium position. When you release the string, it returns to its equilibrium and passes through it. This generates a pulse of a wave, travelling along the medium of the string. This pulse then meets a boundary which it cannot pass. It hits the end of the string which is tied down. The section of the string wants to make the next section of the string vibrate, but it can't, so instead it continues on its own motion. If the string met a boundary at a peak, it would leave the boundary as a trough. This is how reflection of a wave can be described. This pulse then continues back along the string until it reaches the boundary at the other end and is reflected again. Whilst this pulse is moving up and down the string, the original section of the string is still vibrating. There was nothing to stop it at the equilibrium position, so it kept moving through and oscillating. This in turn oscillated the next section of the string, so that a continuous wave was generated. These pulses of the wave will travel forward until they meet the reflected pulses of the wave from earlier. The reflections are travelling in the opposite direction to the new pulses, and so they will interact with each other. For a stationary wave, these waves must interact to form a new overall wave. The individual sections of the two travelling waves interact to form a new wave that appears stationary on the string. The peaks merge with peaks to form big peaks, the troughs form with other troughs to form big troughs, and the peaks and troughs cancel each other out. The fractions of waves interact with each other other fractions of wave to form other fractions of wave. If the two waves are not arranged in the exact way, they will not interact with each other to form a new standing wave. If the string is too long, the waves being reflected will not interact with the new waves at the right point, and so not interact correctly. In one scenario, you will produce no wave overall, and in most others, you will generate a chaotic wave that has no overall pattern. Standing waves are harmonious. You can tell a standing wave on a guitar because the note sounds good. Humans are very well tuned to detecting standing and non-standing waves. A cacophony is a collection of non-standing waves, where all the waves interact to create a mess.